So members, now we are going to see how we draw a curve and its inverse. We are going to start with this simple question. I've done some parts, but of course I'm going to explain so that we can have a shorter video. So given that y is equal to this, show that the curve y has no turning points. On the same axis, sketch y and g of x. You see g of x is 1 over y, meaning it's the inverse of y. So this is, in simple terms, we are going to see how to sketch a curve and its inverse. For more topics about curve sketching, you can visit the playlist there. You will see more examples. So now we start by saying, show that it has no turning points. Of course, we know that to get turning points, we differentiate the curve. But because this curve is rational, we use quotient rule. This is going to be our u. After expanding this, we get this. After expanding this, we get this. This is our u, this is our v. Of course, no quotient rule says the y dx will be v du dx, or you differentiate v, you differentiate u over v squared. And so after doing that, this is now simple calculus. Our v is here, when you differentiate this, you get this. Then our u is there, then when you differentiate v, you get that over v squared. But we all know at turning points, the first derivative is 0. Why? Because at turning point, we assume that the curve has no gradient. That's why we said y dx is 0. Equating now this to 0, it means that when I cross multiply, this will vanish and I'll be having only the numerator. That's why you see here, I don't have the denominator, because when you put here now 0, you cross multiply, the whole of this will vanish. Then now, our task is to expand this and we simplify. And after expanding and simplifying, we shall end up with something like that. Dividing through by -2, we have something like that. So now you know, this is the equation that will give us the x coordinates of the turning points. But now if you check them, if you compare, this is 1, this is -4, this is comparing it with the general quadratic equation, you see that the discriminant is -8. Which is less than 0, meaning that now this equation, this quadratic equation, can never give you real values of x. So meaning if you don't have real values of x, then you cannot get the turning point. So since the discriminant of this quadratic equation is less than 0, it means that there are no real values, hence no turning points. So now we have finished part A. We have shown that the curve has no turning point. That's how we conclude there. Because this one is going to give us non-real roots or complex roots. So it can never have real values. So now, sketch the curve. So now, to sketch the curve, of course, we are going to start by sketching this. To sketch this, we need first of all intercepts. So I come here and I say my intercepts. Of course, the question won't tell you to get them, but of course you need to get them. Then you say, when x is 0, what are the values of y? When you put here 0, you have 0 up, and down you have 4. So it's that our y is going to be 0. So which intercept is that? The intercept we are getting 0, 0. That's the intercept we have there. Then we come for when y is 0, what will be x? Now we put here 0, so we have 0 equaling to x squared minus 3x, the whole over x squared minus 5x plus 4. Then when you simplify, is that there, x into x minus 3 will be 0, and cross multiply, this goes. So you have either x is 0 or x is 3. So now our intercepts there, 0, 0, which we have already. Then the x here is 3, then y is 0. And those are the two intercepts we have. We have this and this because this is the same as that. Then from there, we come to asymptotes. We start by getting the vertical asymptotes. Vertical asymptotes. So for the vertical asymptotes, we said we equate the denominator of the curve to 0. Our denominator is here. If we equate it to 0, so that now we have x minus 1 into x minus 4 equaling to 0. That's how we get the vertical asymptote. So here x will be 1, comma, x will be 4. That is it. So allow me to divide this shortly. For now, I'm going to divide it like that. Now from here, you see that now we said, when you look at this, the power is the same. We said if the power is the same, then we divide through by x with the highest power. So when I divide here, now here I'll be having now specifically horizontal asymptote. Horizontal asymptote. That's what I'm getting. We divide through with the highest power. When the power is less than the power in the denominator, we divide, or even if the powers are equal, we divide through by the highest power. So instead I'm going to divide through by the highest power here. The highest power, the term the highest power is x squared. So divide here by x squared, I have 1 minus, divide here by x squared, we shall be having 3 over x over, divide here by x squared, we have 1 minus 5 over x, is it? Then plus 4 over x squared. We divide through by the term of x with the highest power, if the powers are the same. So you then see here, as x tends to plus or minus infinity, then our y will tend to 1. Because infinity divided by something divided by infinity, we get 0. So this will be 0, 0, 0. You'll be having 1 divided by 1. That's why we come up with something like that. So now our horizontal asymptote becomes y is equal to 1. Then, if the curve has no turning points, there is a possibility of the curve intersecting with this horizontal asymptote. So now we check for the intersection between the curve and the horizontal asymptote. So this happens always if the curve has no region of restriction or has no turning points. So to check for the intersection, is that our horizontal asymptote is y is equal to 1. Now if we put it here, then we simplify. So this would be equal to x squared minus 3x over x squared minus 5x plus 4. If you cross multiply, now this is over 1. Cross multiply, there we have x squared 5x plus 4 equaling to minus 3x. So when I take this side, I have 4. You see this one is going to cancel. So I have 4 equaling, when I take this, it will become a positive. So negative 3x plus 5x, I get 2x. So my x here comes a 2. So meaning there is an intersection between this horizontal asymptote and our curve, and that intersection is 2, 1 is the point of intersection So that is it. So meaning that this horizontal asymptote and the curve, they are going to intersect at 2, 1. The only remaining thing now to sketch, remember we first sketch this, then we shall come to the inverse itself, and I'll give you the techniques there. So now we check for the behavior of the curve, behavior or the nature, behavior of the curve. That curve is y in simple terms, behavior of y. So there we get the critical values. So here, come and we get our critical values. How do you get the critical values of the curve? We get the critical values by equating the denominator and numerator to 0. When I equate this to 0, it's that I have the first critical value as x is equal to 0 and x is equal to 3. Then I also have, now I equate the denominator to 0. I get x is equal to 1 and x equal to 4. Now from there, we arrange them from big to small, then we analyze them. So you draw a simple table there for analysis. Then I also draw this one here. Then here I put the x, then here I put the sign of y. You know what our y is. So you arrange them from big to small. The smallest is this. So we analyze below the smallest, between the smallest and the second smallest, so between 0 and 1, then between 1 and 3, between x between 1 and 3, Then between 3 and 4, between 3 and 4, then above the greatest, which is x greater than 4. Now we look for the sign of y. So below 0, you see below 0 we have a negative 1. So when you put here a negative 1 or in this curve, then you look out for what we will be having. Then when you get a calculator, you can ably get your calculator as I'm going to get mine here. It's missing there. So when we below 0, below 0, an x value below 0 is negative 1. When you put in negative 1, either here or in this one, you see that this will up will be having a positive, and down here will be having a positive. So you have a positive. So between 0 and 1, a value between 0 and 1, that is 0.5. So when you put here 0.5 in this expression, the sign, which sign of y do you get? So the sign will be negative. Between 1 and 3, there is 2. When you put here 2, you have 2. This one will be negative. So up we have a negative, down we have a negative. So there we shall be having a positive. Between this and this, that is between 3 and 4, we have 3.5. Put 3.5 there. I think we shall be having a negative. Then above 4, we have a 5. When you put there a 5, I think we shall be having a positive. So that is our table. Now let us first sketch the y. To sketch the y, start by getting our intercepts. The first intercept is here, 0, 0, because we have no region of restriction. Because the curve has no turning point, it means it has no region of restriction. Or is that the case? If it has no turning points, it has no region of restriction, and vice versa. So I don't expect a region of restriction here. So the first intercept was 0, 0. Then I have 3, 0, which is here, 3, 0. This is 0, 0. Then I have 3, 0 here. Then the second, I can put now the asymptotes. The first asymptote is x is equaling to 1. Come and then I put my x equaling to 1 there. As you can ably see, it is here. X is equaling to 1. Anything different from the curve, we use dotted lines. So x is equaling to 1 is there. So this is x is equaling to 1. Then the next one is x equaling 4. So x equaling to 4 is here. You also do that asymptote there. So you say I have x equaling to 4. Then the horizontal one is y equaling to 1. So this is our horizontal asymptote there. Y is equaling to 1. So you name them, y is equaling to 1. I think basically we have put, then we have a point of intersection between the curve and horizontal asymptote, and that point of intersection is 2, 1, which is here, and this is 2, 1, our point of intersection. I think that's all we have. We said we use this when we are drawing the curve. So now to draw the curve, I start by saying below 0, we said below 0 means the y being positive means whenever you see y is positive, where do we find the positive values of y? Above the x-axis. That's where we find the positive values of y. So that's what these signs mean. So below 0, you see below 0, it's in the positive. Because we have an asymptote here, this is our asymptote, and we have an intercept, it means that this curve is going to come, it grazes that asymptote, then it touches the intercept there. So you see below 0, it's in the positive above the x-axis, but it has to graze that asymptote, and then it touches there. Then between 0 and 1, it's in the negative. Between 0 and 1, you see it's in the negative. Negative means y. Where do we find negative values of y? Below the x-axis. That's why it's going to be below the x-axis like that. So now this is my curve. It's going to come like that. Then between 1 and 3, it's in the positive. Between 1 and 3, it's in the positive. So it's going to graze this asymptote. It comes. You see now, this is our intercept. point of intersection between the curve and then our horizontal asymptote. Then it comes, it also has an intercept there. So you see between 1 and 3 is in the positive above the x-axis. We said a curve can cross a horizontal asymptote but once, but the curve can never touch a vertical asymptote. That's why you see here my curve is crossing a horizontal asymptote. It can do that but once. Then you go between 3 and 4, it's in the negative, meaning it's below the x-axis. So between 1 and 3, it's in the negative. It's going to come here, then it grazes that asymptote that it can never touch the vertical asymptote. Then above 4, it's in the positive. Above 4, it's in the positive. So it's going to be there like this. It comes asymptote to asymptote. Then it's going to be in that order there. So now that is the y. Now we are going to see how do we put the inverse. I'm going to leave this here, then I'm just going to add on something. So that's how we sketch y. I'm going to try to use a different chalk when I'm sketching. Now we are going to see facts. Hope you are taking note of this because I'm going to clean it. So be there. Okay, now members, after cleaning, I think you took note of the question. Now we are going to see how we sketch the inverse. Now here we need to take some notes. A curve and its inverse have the same behavior. So if we have the behavior of this curve, then it's like this, it's the same as its inverse. You don't need to repeat that. Another note is the inverse of y is the reciprocal of y, i.e. if you want the inverse of y, you get the reciprocal of y. Then the numerator of the curve will always give us the vertical asymptotes of its inverse. So if this is the numerator of the curve, then it will give us the vertical asymptotes of that curve. Now, how do we get the inverse of y? Here they told us that our inverse of y was g of x equaling to 1 over y. So meaning we just get the reciprocal of this. So therefore, our inverse g of x is going to be the reciprocal of this. This goes up and then this one comes down. So we are having now x minus 1, x minus 4, the whole over x into x minus 3. Now this one becomes the inverse of y. So now to sketch this curve, all we need intercepts and then we also need asymptotes. Also what you need to note is the horizontal asymptote of the curve will be the horizontal asymptote of this inverse in most cases, specifically for this question when the powers are the same. Okay, so now here what now we start by getting our intercepts. So I come here and then I get the intercepts, but now of specifically which curve. The curve I'm getting intercepts for is this inverse now. So now I come here and I say my intercepts. So my intercepts are going to be, so we get when x is 0, we get the value there, and we also get when y is, now this time we have g of x, so which is 0. So we start with the easiest. When x is 0, what values are we having? When x is 0, we put here 0. Simple terms. When x is 0, up I have this would be 0. So I have negative times a negative. I have here my g of x as 4 over 0. So when x is 0, which asymptote is that? When x is 0 is a vertical asymptote. And so that this one is giving us infinity. So then here we conclude the curve has no, hence g of x has no vertical intercept. Why? Because we have a 0 in the denominator. So then we come to the other. When g of x is 0, what do we get? If you get now g of x to 0, we shall be having 0 equaling to x squared or x minus 1 into x minus 4 over x into x minus 3. And cross multiply, you have x minus 1, x minus 4 equaling 0. So we have x is equaling to 1 and x is equal to 4. So the intercepts there become x0, the vertical coordinate is 0, then 4, comma 0, and these are now my x-axis intercepts when it's 0. So now what do we need else? We need the asymptotes. So we come to now the vertical asymptotes. So my vertical asymptotes, I equate the denominator to 0. Now this is my denominator for the inverse. So x into x minus 3 equaling 0. So either my x is 0 or my x is 3. These are the two vertical asymptotes. Then when I come to the horizontal, because these powers when I try to expand they are the same. So now my horizontal asymptote, we try to expand. When I expand this, is that my g of x will be equal to x squared minus 5x plus 4 over x squared minus 3x. So the powers are the same. I divide through by the s power, which will give me now, okay, my g of x here will give me 1 minus 5 over x plus 4 over x squared, the whole over 1 minus 3 over x. So if I try to borrow this part here, so now as x tends to plus or minus infinity, my g of x will tend to 1, and therefore our horizontal asymptotes becomes 1. So because of course the inverse, if the curve has no region of restriction, even its inverse has no region of restriction. So then from there we check for the point of intersection, which is going to be the same. So the point of intersection between the horizontal asymptote of this curve and then that of its inverse, they are always going to be the same. So point of intersection, we take for that point of intersection. Now we have g of x is 1 is equaling 2. Now when we try to expand this, I have x squared minus plus 4 over x squared minus 3x. Always it's going to be the same. But anyway, if we cross multiply, you have x minus 3x equal to x squared minus 5x plus 4. This one cancels, and I bring this, I get 2x equaling to 4. So my x becomes a 2. So then point of intersection becomes 2, 1, which is the one we got there. Always, anyway, that one works, but here it won't work anyway, after all. So it's that here we just have a point of inflection there, in that inverse there. So members, that's all we need. We said now we have the intersection. Now by this one, we're now dealing with the inverse. So now to sketch it, you be careful. I'm going to even use different chalk color, the color. So here now we have the intercept as 1, 4. The intercept as 1, 4. The intercept as 1, 4 and 4, 0. I come now, I come 1, 4. 1, 0 is the first. 1, 0 is here. So our 1, 0, let me use red chalk. So 1, 0 is our first intercept. 1, 0. Then the other one is 4, 0, which is here. Now don't confuse. This is now I'm on the inverse. Then the next one, I'm going to be having now, I think the only thing remaining are the asymptotes. Now the asymptotes I have x is equal to 0. So you come and you put our x equal to 0. Is here, this is the line x is equal to 0. So now I'm going to draw just close to the y-axis, as you know always. So this is my x is equal to 0. So I'm trying to draw a line just close to that x is equal to 0. So this is my x is equal to 0. Then also x equal to 3. So my x equal to 3 is just here. So x equal to 3 is there. These are asymptotes of the inverse. Don't confuse them. So what are we missing? We have the intercepts. We have no vertical because it gave us an infinite value. We have now the horizontal asymptote, which is the same already here. It passes through 1. So we have it there also. Now, to sketch, we said it has the same behavior. Below 0, this is below 0. It's in the positive. We said once the curve, by the way, listen to this, always the curve is, and they are going to be in the same region. So, because here, we have it here, we said here, below 0 it's in the positive. And because we on this, the inverse has no intercept anywhere, so it's going to be in the positive. That's why this is an asymptote for it, and this is an asymptote. So, it's going to be in that shape. This color is blue. Try to differentiate. Then between 0 and 1 is in the negative. Between 0 and the 1, it's in the negative. Now in the negative, because I have an intercept for this inverse here, and this is its asymptote, it's going to come there. It raises it like that downwards. Then we have between 1 and 3, it's in the positive. Between 1 and 3 in the positive, and it has a point of intersection there, so I draw it like that. Then, because this is the asymptote to the inverse, this x is equal to 3 to the inverse, it's going to come then, it raises this like that. It does not touch it, because it can never touch its asymptote. Then, between 3 and 4, between 3 and 4 it's in the negative. Between 3 and 4 it's in the negative. 3 and 4, it has intercept here, so it means it has to come here. Then it goes down like that. Then above 4, it's in the positive. It has intercept here, it's going to come. Then it cannot cross this again, because we said a curve can cross a horizontal asymptote only once. It has already crossed it here, then it can't cross it there. So basically, that is the curve and its inverse. This is our inverse, which is g of x. So this is our g of x. This is our g of x. Then this is also our g of x. Then this is our y. The original curve. This is our y. This is our y. And this is our y. So that's how we sketch that. So that's how members will sketch a curve and its inverse. Always you base on the behavior. As simple as that. That's it, members. I wish you well. Don't forget to subscribe to the channel. Now there are more examples of how we sketch parametric equations. Curves with parametric equations. You can go to the playlists and see more of that. Otherwise, I wish you well.